We're on problem 195. And they have drawn a little bit of a grid here. Let me try to draw it as well. 1, 2, 3. And they do the same thing the other direction. 1, 2, 3. And they call this First Street. Oh, no, there's actually 4 going that direction. Let me draw that one. So there's another street like that. And they call this First Street, Second Street, Third Street, Fourth Street, and Avenue A, B, and C. And they say that this point right here, I'll do that in a different color. That point right there is X, and that point right there is Y. Pat will walk from intersection X to intersection Y along a route that is confined to the square grid of 4 streets and 3 avenues shown on the map. How many routes from X to Y can Pat take that have the minimum possible length? So essentially, minimum possible length, he doesn't waste time. Right? So let's think about it this way. So he could go this way. So we could think about how many different ways can he get to each point on this graph, right? So to get here, to get there, there's one way, right? One possible way. To get there, this seems to be a very similar problem with what I saw in a computer science exam a long, long time ago. But there's one way to get there, right? That's obvious. So how many ways are there to get here? Well, you can view it as to go from this path to this path, and this path to this path, you can sum the 2 ways to get there. So it's 2, right? Which makes sense. You go like that, or you could go like that. How many ways are to go here? Well, there's only one way to go here, right? Likewise, only one way to go here. Now, this is where it gets interesting. How many ways are there to go here? Right? I can either come from there, and there's only one way to get there, so that's one path, or I could come from here, right? But there's 2 ways to get here. So there's 2 ways to get here via this path, and there's one way to get here via this path, so there are 3 ways to get here. So essentially, I just added the 1 and the 2. And you think of the same logic here. How many ways are there to get there? Well, I can come via this path, and that'll be and there's only one way to get here, so there's only one way to get from this direction. Or I could come from this direction, but there's 2 ways to get here, so there's 2 ways to come from this direction. So there's 3 ways to get from that direction. Right? And we could use the same logic. There's one way to get here, right? You just go straight up. How many ways are there to get here? Well, one way to get there, 3 ways to get there, so there are 4 ways to get here, because you can go through that one way or through these 3 ways. Similarly, how many ways are there to get here? You go 3 ways to there, 3 ways to there, and I can come from either here or here, so there are 6 ways. Right? So how many ways to get to Y? 4 ways to get here, 6 ways to get here. 6 plus 4, 10 ways to get here, right? I could either come from one of the 6 ways from this direction or one of the 4 ways from this direction. So 10 ways. And that is choice C. Next problem. 196. 196. The ratio by volume of soap to alcohol to water in a certain solution. So soap to alcohol to water is equal to 2 to 50 to 100. The solution will be altered so that the ratio of soap to alcohol is doubled, while the ratio of soap to water is halved. So soap to alcohol will be doubled, and then the ratio of soap to alcohol is doubled, and the ratio of soap to water is halved. Okay? If the altered solution will contain 100 cubic centimeters of alcohol, how many cubic centimeters of water will it contain? So let's think about what the new ratio is. The old ratio of soap to alcohol, right? The old ratio of soap to alcohol was 2 to 50. Now they want to double this ratio, right? So the new ratio of soap to alcohol is going to be 4 to 50. Fair enough. Now the old ratio of soap to water was 2 to 100. 2 to 100. Now what's the new ratio of soap to water? It was going to be halved, right? So that equals soap to water. But we want to halve this ratio, so now the new ratio of soap to water is 1 to 100, right? So let's see how we can think about it. If we rewrite this, if we rewrite, and let's write this as a ratio of 4 to a something. So that's the same. 1 to 100 is the same thing as 4 to 400, right? 4 to 400. So let's see if we can rewrite these ratios. So the ratio of soap to alcohol to water now becomes 4 to 50, and the ratio of soap to water is 4 to 400 to 400. So they give us alcohol and they want to figure out water, right? So what's the ratio of alcohol to the ratio of alcohol to water is equal to 50 to 400, and that's another way of saying 1 to 8, right? Alcohol to water is equal to 1 to 8. Let me see if that's is 1 to 8, and they're saying that we have 100 cubic centimeters of alcohol. So how much water? So 100 over water is equal to 1 to 8. And you could even eyeball that. That's 100 over 800. So water has to be equal to 800 cubic centimeters. And that's choice E. Next question. Next question. 197. If 75% of a class answered the first question on a test correctly, so 75%, so let's say 3/4, question 1 correctly. Question 1, 55% answered the second question on the test correctly. Oh, let me write it this way. Question 1, 75% true. Question 2, 55% answered the second question correctly, and 20% answered neither of the questions correctly. So 3, 20%. So that's not question 3. 20% neither. What percent answered both? What percent answered both correctly? Okay. So 3/4 answered question 1 correctly, and 1/4 answered it incorrectly. Q1, they got it wrong, right? Now, they're telling us that 20% got neither correct. So that means that they got Q2 wrong as well. Q2 was wrong as well. And this is 20% of the entire population. So this is 1/5. This is 1/5 of the entire population. So my question is, if this is 1/5 of the entire population, what fraction of this population was it? Well, of these people, the fraction that got it correct, got Q2 incorrect, let's write that as x. So x times 1/4 is equal to 1/5. Multiply both sides by 4th, you get x is equal to 4/5. So what we know is, since this is 1/5 of the entire population, that of the people who got question 1 incorrect, 4/5 also got question 2 incorrect, right? And if you want to know what percentage that is of the whole population, multiply 1/4 times 4/5, and you get 1/5, which is that data that they had given us. But this helps us because this tells us of these people who got question 1 incorrect, what fraction got it right, got question 2 right. Well, 4/5 got it wrong. 1/5 got question 2 correct. 1/5 got question 2 correct. All right. So now let me just take a step back. I want to make sure I'm not doing it the slowest possible way. They told us that, right, 75% got question 1 right, and then 55% got question 2 right. Okay, so let's think about it. So of this, some percentage got question 2 wrong, right? Or actually, let's think of it this way. Of this, some percentage got question 2 right. Let's call this, I don't know, let's call this y, right? Let's call that y, and let's call this right here, let's call this, I don't know, I already used, well, I'm going to use x again. Let's call this x. Well, yeah, I'll use x. This is a different x. All right. So first of all, what is the total proportion of people who got question 1 wrong and then question 2 right? Well, it's 1/4 times 1/5. So it's 1/20th of the people got question 1 wrong and question 2 right. And that's equal to x. Now, what percentage of the people got question 1 right and question 2 wrong? Well, that's going to be y, right? Now, if you think about and y is actually what we're solving for. They want to know how many students answered both correctly, right? So, if you think about it, y plus 120, that represents all of the people who answered question 2 correctly, right? All the people who answered question 2 correctly, I know it's a little confusing, are those people and those people, right? That's all the question 2's answering correctly. We already know that this is 1/20th of the population. And we know that y plus 1/20th of the population is equal to 55% of the population. So we could write that as 55 over 100, or we could divide both by 5, and you get 11 over 20. This is 11/20ths of the population. So what is y? We'll subtract 1/20th from both sides. Y is equal to 11/20ths minus 1/20 is equal to 10/20ths, which is equal to 1/2. So 1/2 of the population got both the first and the second question right. And actually, we didn't even have to use, well, we did have to use this 3/4 information to get this 1/4 here. But anyway, and let's see if that's one of the choices. Right, D, 50%. And I'm all out of time. See you in the next video.